Hi, this is Josh Wheel. I'm the HVAC Technical Service Manager at the RF Egger Company, and welcome to our YouTube channel. In this video, I'm going to demonstrate how to measure superheat and subcooling on an air conditioning system. And why is superheat and subcooling important? It's important in being able to troubleshoot the system and verifying that our refrigerant charge is correct. The two tools that are needed to measure superheat and subcooling are a thermometer, some type of clamp-on temperature reading device, because we need to measure the line temperatures of both our suction line and liquid line, and obviously our refrigerant gauges. So the first measurement I'm going to take is superheat, and I'm using a field piece multimeter with a thermocouple attachment, and I'm going to let this give us a second to settle out. I prefer a clamp-on type probe versus a thermocouple using electrotape. I just tend to think we're getting more surface area and a more accurate temperature reading. So I really prefer a clamp-on type device when measuring the line temps. So the first thing we're going to look at is what is our suction line temp. We're going to measure superheat first, so we need to know what our suction line temperature is. And we want to measure it fairly close to our service valve. You can see, looking at my field piece meter, I've got about 47 degrees on my suction line. So I need to notate that number, and now I need to go to my refrigerant gauges, and I want to look at my suction pressure. And you can see I'm about somewhere between 120 and 125 PSI. And if I follow my line down to this inner pink dial, that's where my saturation temperature is. And you can see I'm reading at about a 41 degree saturation temperature. So when it comes to superheat, I'm going to take the saturation temperature number and subtract it from my actual line temperature. So I'm reading 41 degrees on my saturation temperature on my gauge, and I'm reading 46 degree line temperature. So 41 minus 46 means I have 5 degrees of superheat. Superheat means I have a vapor. Probably the worst thing for a compressor is having liquid flood back to it. So knowing I have superheat lets me know I have vapor coming back to the compressor, and I'm not going to slug it. The next reading I'm going to take is the subcooling reading. This is an expansion valve system at the indoor evaporator coil. So I need to know my charge is right. I'm going to measure subcooling. I'm going to take my clamp-on probe, and I'm going to move it to the liquid line. Give this a second to stabilize and see where our temperature ends up at. And you can see we're at about 74 degrees. We're still climbing a little bit. And we're at about 77 degrees. The next thing I'm going to do is I'm going to grab my gauge again, and this time I'm going to look at my high side pressure, and I'm going to do the same thing I did with superheat, is I'm going to convert my pressure to a saturation temperature. And you can see that I'm at about, it looks like 265 PSI. And that converts to about 87 degrees saturation temperature. I take my actual line temperature, which seems to have settled out around 80 degrees, and I subtract that from my saturation temperature. So I have 87 minus 80, lets me know I have 7 degrees of subcooling. Now I can refer to the manufacturer specification and determine if my charge is right. If my subcooling's low, I would add refrigerant to bring it up. If my subcooling's high, I would take some out to bring it down to try to get into the manufacturer specification. So both numbers are very important when you're trying to troubleshoot a system, to know that the charge is right, that the metering device is working right, that we have good airflow. All of these things we need to know to be able to try to diagnose and find out what the root cause of the problem is with our system. So thank you for watching our video and have a great day.